problems of chemical reactions and equations. Okay, so you're most welcome to this problem solving session. Let's start with our first question. The question is, food scraps are turned into compost in a compost pile is a dash change. Now could you get what type of change it would be, whether it's a physical or a chemical change? Just turn back your pages of books, and what is there? Food scraps are turned into compost. Now what are these food scraps composed of? They are composed of carbohydrates, proteins and fats. Now what is done here is that the food is placed in a compost pit and there certain changes occur. Now here students, the changes occur in its chemical composition. Few gases are released, gases like carbon dioxide is released, methane is formed or ethane is formed, right? Proteins are decomposed to form ammonia. So now what type of a change it is? It is a chemical change, right students? Now our next question is, a piece of wood is crafted into a shape which allows a batsman to apply force on the ball. What type of change it is? So could you guess what type of change it is? Is this wood undergoing any change in its chemical composition? Now do you know what is this wood made up of? Wood is formed of hydrocarbons. Hydrocarbons, that is carbon, hydrogen and oxygen, which are bonded in a specific manner, right? Now, is this wood changing its chemical composition when it is crafted into a bat? No, there is no change in its physical composition. Now tell me, is there change in its state? No, there is no change in its state, solid and solid. Fine. What is the change here students? The change is in its shape, right? So only shape is changed. Okay, rest of the properties of the wood are intact. The chemical property of the wood is same, right? So what type of change it would be students? It would be a physical change. As we know that in a physical change, what happens? The state changes or the shape changes, but the chemical properties remain the same. Got this point? Now let's move to our next slide. Now here is a question students. Clotting of blood using alum is a dash change. Now could you guess how or why the blood clots if you are using alum, or if you are using ferric hydroxide? Ferric hydroxide is what? What is ferric hydroxide? It is Fe3OH whole twice. I'll write its formula here. Ferric hydroxide. Now what type of change it is undergoing students? Just tell me the type of change. We are using a chemical like ferric hydroxide or alum. Alum is what? Alum is sodium it is a potassium and aluminium salt, right? So it is a double salt, right students? Alum is composed of potassium hydroxide, aluminium hydroxide and water, and water. Right students? Now what are we doing is that whenever there is a cut or there is a bleeding, we are putting this alum or ferric hydroxide, right? So what happens? That your blood clots. Now why it is clotting? Because these chemicals which you are using are changing the chemical composition of blood there. The blood coagulates. Getting my point? The blood coagulates or the blood precipitates. Now students, what is the charge on blood? Just tell me, is it negative or is it positive? It is a negative charge on blood particles, now which is coagulated by either aluminium ions, which is present in alum, or potassium ions, or your ferric hydroxide ion. So what is the formula of ferric hydroxide? Formula of ferric hydroxide is, what is it? FeOH whole thrice. It's not Fe3OH whole thrice. Okay, so it is ferric hydroxide. Fe, I had written it wrong here. I'm very sorry for that. FeOH whole thrice. Got my point, students? So this is what type of change? It is a chemical change. Fine. That is, your blood is getting clotted. Okay. Now your second question is, change in odor, color or formation of precipitate is a dash change, right? So change in odor, I think its spelling should be O-D-O-U-R. I'll correct it here. So change in odor means odor is the smell, right? Say if I take the example of fruit, so the smell of the fruit changes. Why? Because the content, the sucrose or the sugar present in the fruit is getting fermented. Or there is change in color also, right? Change in color, for example, we discussed a chemical reaction between sulfur dioxide and acidic potassium dichromate. When sulfur dioxide is passed through acidic potassium dichromate, the color changes from orange, right? So its color changes. Likewise, formation of a precipitate. Now what is a precipitate, students? I told you, it is a solid substance which is deposited or which separates out from the solution, okay, in a chemical reaction. So all these are what? These are chemical changes. That is, there is change in the chemical composition of the substance. Okay? Got it? Now let's move to our another question. It is that mass of individual substances that undergo change always either increases or decreases. What type of change it is? It is that the mass of the substance is either increasing or decreasing. The mass doesn't remain the same. For example, if I am chopping or cutting wood into small pieces, what will happen? That there will be no change in mass. Say I am taking a log of wood of suppose 10 kgs, and if I am cutting it down into small pieces, will there be any difference between the weights of the pieces of log and intact log? No, there is no change in mass, right? Or if I am tearing paper, then also the mass of torn paper and intact paper doesn't change. Got my point? Now here, what is it saying? That there is change in increase or change in mass of the individual substance. Okay, so for example, I'll write down an equation here, the most simplest one, that is, if I'm writing this, if I'm forming H2 gas reacts with Cl2 gas, and it is forming what? It is forming twice of HCl gas, of course, right? Now in this case, students, mass of hydrogen is different, mass of chlorine is different, and you are getting hydrochloric acid that has got a different mass. Okay, so what type of change it is, students? It is chemical change, right? Now according to law of conservation of mass, what happens? That mass is neither destroyed nor can be created. So what happens, students, that the mass of this total substance, that is the mass of reactants plus the products, it remains same, right? There is no change in the total mass of the substance. Got my point? So the answer of this question would be a chemical change. Okay, I'll write it here, that would be better. So it's our conclusion is that it is a chemical change. Okay. Now students, there is a next question, that is latent fingerprints invisible to eye are made visible by dash change. Now what do you mean by these latent fingerprints? So students, you must have seen episodes of CID or any crime investigation. What they do is they take the fingerprints on a glass or on a gun or any weapon which the suspect has used, right? But those fingerprints, students, they are invisible. Now when they want to see it, what they'll have to do? Now on the fingers of a person there is sweat, it has got some proteins, or there is some contamination of either oil or paint or any other chemical, right? Now those fingerprints are made visible by putting in some chemicals into it, right? Chemicals like ninhydril or acrylate, right? So these chemicals are put on those fingerprints and they are made visible. So what type of change is it, students? It is a chemical change again. So is this question clear? Right? So this is also an example of chemical change. Now let's take another next question, that is, your question is, milk becomes sour if kept for a long time. What type of change is it? So students, what is the chemical composition of milk? What is it? Milk contains lactose. Lactose is a sugar. Okay, now if I'll write here that milk is having what, students? The first question of this part, milk has lactose. Now if you are keeping it for a long time, what happens, students, is lactose gets transformed to lactic acid, right? This lactose is a sugar which is present in the milk. Now this is acted upon by microorganisms like bacteria, and this bacteria is changing what? Lactose to lactic acid. Okay, now because of this lactic acid, your milk is becoming sour. Got my point? So what type of change is this? This is a chemical change. Okay, is this question clear? Right. Now let's move to our next question. Water evaporates from the surface of the ocean. It is a dash change. Now just try to imagine it. What is happening in this case, students? That your water is evaporating. What change is occurring there? There is change in state, right? So I'll put it here. While evaporation, what is happening? There is change in state of water, right? It is changing from liquid to vapor state or gaseous state. Now just tell me, when it is changing in its state, is there any change in the composition of water? Do you find any change in the composition of water? No. There is no change. The composition of water still remains what? It is H2O only. Got my point? So, students, composition of water has not been changed. It is still H2O. Okay? So, what type of change it would be, students? It would be again a physical change. So I hope this question is clear to you. Or we can say in glaciers, what happens? That water freezes. Again, what is there, students? There is change in state of water. Right? Water has been changed from liquid to solid state. Fine. So what type of change it would be? It would be a physical change. Fine. Now let's take another question. Now what is this, students? This is an equation. H2 plus O2 gives H2O. Now what is the question? The balanced equation for the given equation has dash coefficients. Now students, what do you mean by coefficients? Right? Coefficients are the numbers which are placed in front of the atom or the molecule. Okay? So how can we balance it? Just I have told you this balancing in my session of balancing chemical equations. So I can just summarize it here. That just count the number of atoms on LHS and RHS. Okay. Now how many atoms? Let's write it here. LHS and RHS. Okay. So, on the LHS side, how many hydrogen are there, students? There are 2 hydrogen atoms. On RHS side, how many hydrogen are there? There are 2 hydrogens. On LHS side, how many oxygen are there, students? There are 2 oxygens. But on RHS side, how many oxygens are there? There is a single oxygen. Okay? Now, how could we balance it? Just tell me, how are you going to balance it? You have to make it H2O. Now, if I am putting 2 in front of H2O, what I'll get, the equation I'll get is H2 plus O2 gives 2H2O. Now, is it that our oxygen is balanced? Now we have got 2 oxygen atoms on LHS side and 2 oxygen atoms on RHS. But students, what about hydrogen? We have got how many hydrogen on LHS side? We have 2 hydrogen on LHS and how many hydrogen on RHS? We have got 4 hydrogen on RHS. So how can I balance it? I can make hydrogen on RHS also 4 by adding 2 in front of hydrogen. So it will be 2H2 plus O2 gives 2H2O. Now students, is our equation balanced? I have got 4 hydrogen on RHS, 4 hydrogen on LHS, 2 oxygen on RHS, 2 oxygen on LHS. So what are the coefficients which we are using in this equation? It's 2 and 2. So what will be the answer of this question, students? It has, I'll write 2, that is, I'll write it here, 2H2 and 2H2O. Got my point? So what are the coefficients here? Coefficients are 2. This is 2 and 2. Right? So this is about balancing this equation. Now let's take up our next question. So it is a big equation. What is this compound, students? This is a symbol for aluminium. This is a symbol for hydroxide. So this whole is aluminium hydroxide. You get my point? It is aluminium hydroxide. This is hydrogen chloride or hydrochloric acid. When these are reacting, what am I getting is aluminium chloride and water. Okay, students. So I have got this thing. Now I want to balance it. So I assume that you know how to balance. This I have done in my presentation or in my lecture on chemical balancing of equations or balancing of chemical equations, sorry. So what I can do here is, how many chlorines are here? 3. So if I put 3 here, what I'll get is, my equation will become aluminium hydroxide OH whole thrice plus thrice of HCl, and I am getting AlCl3 plus of H2O. Now is my equation balanced, students? Chlorine, the number of chlorine atoms is 3 and 3. Right? Number of aluminium is 1 and 1. What about water, students? How many hydrogen is there? 6. How many oxygen is there? 3. So what is the coefficient I'll have to put here? I can put here 3H2O. So I'll simply write here 3H2O. Okay. Now, is our equation balanced? Aluminium hydroxide 3HCl gives AlCl3 plus 3H2O. 1 aluminium, 1 aluminium. 3 oxygen, 3 oxygen. 3 plus 3, 6 hydrogen. 3 twos are 6 hydrogen. 3 chlorines, 3 chlorines. So our equation is balanced. Okay. Now what will be the coefficients I have used? I have used 3HCl and 3H2O. So what all coefficients it has, students? It has 3 on the reactant side and 3 on the product side. Okay. So now our equation is balanced. I hope this is clear to you. Right? Now let's move to our next question. This is also a bigger question. It is PB solid. What is PB, students? PB. PB is lead. The symbol for lead is PB. Right? It reacts with copper chloride. Right? It is cupric chloride. Now students, there is a difference between cuprous and cupric. Okay. Now if I write Cu2Cl2, it is cuprous chloride. And if I am writing CuCl2, it is cupric chloride. Right? Now this is reacting with cupric chloride, giving lead chloride, okay, and copper. Now what is your question? It is a dash type of reaction. So students, how many types of reactions are there? There is combination reaction, decomposition reaction, your displacement reaction and double displacement reaction. So what is happening here, students? Your lead has displaced copper. Okay, that's why we are getting lead chloride here. So what type of reaction is this? It is a displacement reaction. Okay, so what will be coming in the fill up is displacement reaction. I'll write it here. Displacement reaction. What has displaced what? Lead. PB has displaced copper. Right? From where? From copper chloride, cupric chloride, CuCl2. Okay students, so this is what type of reaction? It is a displacement reaction. Let's take next question, that is zinc oxide solid with carbon monoxide gives zinc solid plus carbon dioxide. Okay, now your zinc oxide is reacting with carbon monoxide and forming zinc solid. Now just tell me students, what is oxidation? What is oxidation? Oxidation is addition of oxygen, right? Or the one, this is addition of oxygen. And what is reduction students? Reduction is removal of oxygen. So what is happening here students? In this case, from where the oxygen has been removed? From this zinc oxide, oxygen has been removed and it is forming what? Zinc solid. To which molecule oxygen is added? Carbon monoxide, and it is forming what? Carbon dioxide. So what is oxidized here students? The carbon monoxide is oxidized. I'll write it here. What is oxidized? It is carbon monoxide is oxidized, and what is reduced? From where oxygen has been removed? Zinc oxide. Zinc oxide is reduced. Got my point? So this is a redox reaction. Why redox students? Because both oxidation and reduction has taken place. Okay. Now let's take our next question, that is, here we have got the things. Oxidation is dash of electrons. What is it? It is loss of electrons. So your oxidation is, I'll write it here, it is loss. Reduction is gain of electrons. Again, oxidation is, in terms of hydrogen, loss of hydrogen. Reduction is gain of hydrogen. Right students? So don't get confused. Keep one thing in mind. Electrons, oxidation. In oxidation, electron is lost. Right? So it will be reverse for reduction. In oxidation, hydrogen is lost. So it would be reverse for reduction. Or I can also present this thing as oxidation is, as I told you in my previous slide, that I'll write it here, oxidation is dash of oxygen. So it is loss of oxygen, a loss of hydrogen, so it would be gain. And reduction would be, tell me what would be reduction? Reduction would be loss of oxygen. So students, these are different ways by which you can define oxidation and reduction. Is my point clear? So keep this thing in mind students. You don't need to remember all the definitions. You just remember oxidation is loss of electrons, loss of hydrogen and gain of oxygen. That's it. Reduction is reverse of it. Okay students? So for this session I'll stop now. We have discussed 10 questions of chemical reactions and equations. I hope by discussing these questions with you, it is clearing your concepts, right? Students, these are the most basic concepts which you will be applying in your higher classes. So make sure that these concepts are very clear to you. Okay students? So practice the questions.